Alright, in this video I'm going to talk about the dot product of two vectors. So I've got two three-dimensional vectors here. So vector A again has components A1, A2, A3. Vector B has components B1, B2, B3. It says to get the dot product, all you do is multiply the respective components, A1 times B1, A2 times B2, A3 times B3, and then add them together. Okay. Notice that the dot product is a number. Okay, it's not. When you take the dot product of two vectors, you get a number. You don't get another vector, okay? Whereas the cross product, if you take the cross product of two vectors, you do get a new vector. And some useful applications of this dot product, it says, so one little theorem here says that, it says if theta is the angle between vector A and vector B, it says the relationship that holds is if we take the dot product between vector A and B, that's going to be equal to the magnitude of A times the magnitude of B times cosine theta. Or equivalently, if we solve, it says we get A dot B divided by the magnitude of A times the magnitude of B equals cosine theta. And a corollary of that says that two vectors are going to be orthogonal or perpendicular if and only if their dot product equals 0. Okay, so a couple useful little results that come out of the dot product result. So let's just do a couple examples here. So the first one's just going to be straightforward. Let's just find the dot product, A dot B. Okay, and in my first problem here, I'm just going to let vector A equal 2, 5. We'll let vector B equal -3, 1. So it says the dot product, A dot B, will take 2 times -3, and then we'll add on to that 5 times 1. So this will simply give us -6 plus 5, or, hey, -1. That's the dot product between these two vectors. Okay, so that's it. So pretty easy to find the dot product of two vectors. Let's find the angle between the two vectors, and so let's suppose that vector A is 6i minus 2j minus 3k, and let's suppose that vector B is I plus j plus k. Turn on an extra little bit of light here. So vector I plus j plus k. So again, I can rewrite this as 6, -2, -3. And then my other vector will be 1, 1, 1. So maybe not the most exciting other vector here, but keep the arithmetic easy. So it says the angle cosine theta, it says that's going to be equal to the dot product A dot B divided by the magnitude of A times the magnitude of B. Okay, well I talked about in a different video how to find the magnitude. So let's take the dot product. It says we'll have to take 6 times 1 plus -2 times 1 plus -3 times 1. The magnitude, we'll have to take the first one and square all the components, so 6 squared plus -2 squared plus -3 squared. That'll be the magnitude of the first component, the first vector rather. And then we'll get 1 squared plus 1 squared plus 1 squared when I find the magnitude of the other vector. So if we simplify this down here a little bit, what do we get on top? It looks like we get 6 minus 2, which is 4. 4 minus 3 is going to be 1 on top. And then on the bottom, it looks like we get some fairly big numbers. So 36 plus 4 is 40. 40 and 9 will be 49. And then the other, it looks like we get 1 plus 1 plus 1, or simply the square root of 3. So if we multiply these two together, it looks like we'll get 1 over the square root of 147. Alright, so if we take, now we need to solve for our angle theta. So what we do is we take inverse cosine of both sides. So we'll get theta on the left, and we'll get inverse cosine of 1 over the square root of 147. And I got this to be roughly to equal the angle 85 degrees. Okay, so it says the angle between these two vectors in this case is simply going to be 85 degrees. Okay, so a useful little application of the dot product along with the magnitude. Alright, one last example here. Suppose the question says, where'd my problem go and do? Are the vectors orthogonal or not? Okay, so again, we said two vectors are going to be orthogonal if their dot product is 0. So suppose vector A has components 2, 4. Let's suppose vector V has components 4, -2. Well, the dot product of these two vectors will be 2 times 4. Again, we multiply the first components, plus 4 times -2. We multiply the second components and then add them together. Well, this is 8 minus 8, or 0. So yes, the vectors are orthogonal. And you could even get that from graphing these two vectors. Okay, so the vector 2, 4, that means you go 2 units over, 4 units up. This would be your first vector, vector A. Vector B, it says you go 4 units over and then 2 units down. So this would be vector B. Okay, and if you imagine extending this along, certainly these vectors look like they would be crossing at right angles. Okay, so again, computing the dot product isn't hard, but some useful little applications, some useful results certainly come from it.